Let me welcome you here for the inauguration of the MIDI conference. This is Dr. Wisław Kopeć.
And here with me is Dr. Cezary Bile.
Thanks. And we'll be host for our today's meeting and also for the next days of the conference that will take place in the online form. First, I would like to invite Vice Rector of the Polish-Japanese Academy of Information Technology, our today's host, to say a few words about the conference. Professor Wierzbicki will connect with us using Zoom because unfortunately he was unable to get here today.
Yes, but of course we are in the hybrid mode, so Professor Wierzbicki, the floor is
yours.
Hello,
welcome. Welcome. I would have liked to have been there with you, but I live on the outskirts of Warsaw and I literally snowed in today. So I couldn't come, but it's good that I could be here virtually. It's a great pleasure to cordially welcome all of you, all the participants of the 10th anniversary conference, MIDI conference. And I would like to welcome you all on behalf of the president of the Polish-Japanese Academy of Information Technology, Professor Jerzy Paweł Nowacki. The conference has been established 10 years ago, as you know, by the late Professor Krzysztof Marasek. And at that time, we could not have predicted that it would have grown so much and become a successful forum for scientific and practical exchange of knowledge in the area of machine intelligence, but also in several other areas. As I look at the program today, I can see how interdisciplinary the conference really is, how much there is also about digital interaction and even space exploration. So we have the 10th anniversary. It's the third time the conference is in hybrid mode, and we have many international guests. It's my pleasure to welcome you. It's great to have such a research collaboration at the time, especially right now that the pandemic is already over. And I hope that this is just the beginning of an even greater growth for the conference here. This is also the ambition of our academy, which is one of the leading technical universities in Poland. And we also have the ambition to become an internationally recognized scientific and technical university. So it is our great pleasure to welcome so many researchers and to support so many bold research and development ideas at the conference today. Coming back to space exploration, you may have watched the successful landing of the Orion module of the Artemis 1 space mission recently, yesterday, and you may not know, but this mission actually has Polish sensors on board, and it's an example of right minds must come together to actually make such an endeavor possible. Right, it is an enormous technical and scientific venture. So it has been successful. Yesterday, it successfully touched down, and hopefully we can also do something about the future of space exploration using such technologies such as extended reality, for example, which will also be the topic of the discussion panel that will be one of the opening panels of this conference, together with our scientists and experts from the European Space Agency, from the Polish Space Agency and the Polish Ministry of Education and Science. So I wish you all a very successful conference. I will be very happy to listen and see the most interesting bits online. Thank you very much and have a very successful meeting.
Thank you very much.
Thank you so much.
Okay, the development of the conference as an important forum of exchange of ideas in the IT community has been recognized by Polish Ministry of Science and Education, and this year Minister held our conference under his patronage. And now I'd like to invite Łukasz Wawer, Deputy Director of the Digital Transformation Center at the Polish Ministry of Science, of Education and Science.
All right. Okay. Ladies and gentlemen, I would first like to take the opportunity to thank the conference organizers for the invitation to this captivating event. It's a great honor for me to make a few words on the conference opening. This year marks the 10th anniversary of the MIDI conference, which has become a renowned event among IT centers in Poland and around the world over the past decade. The event is held, as it has been said, under the patronage of the Minister of Education and Science, Dr. Przemysław Czarnek. This indicates that the MIDI conference is an initiative of particular importance to Polish science and education sector. The topics of conference focus on intelligent machines and interactions between humans and new technologies. Artificial intelligence is playing an increasingly vital role in both economy and science. These intriguing issues most certainly merit further exploration. MIDI is a unique interdisciplinary event that brings together social sciences and modern technologies. It accentuates the significance of a new type of relation, the one between humans and machines. This constitutes an intriguing subject for further investigation. The conference agenda illustrates the growing number of scientists who are presenting fresh and varied approaches to these subjects. I eagerly anticipate the results that they will present over the coming days. Once again, I would like to extend my congratulations to the conference organizers for hosting such an incredible event that has provided renowned researchers with an opportunity to come together and collaborate. I sincerely hope that many more editions of the MIDI conference will be held in the future. Thank you.
Very much. Thank you. Thank you very much, and thanks again for the support from the Ministry for our conference.
Yes, speaking of support, as our Vice President, Professor Wierzbicki said, this conference, this 10th anniversary conference, is such an endeavor that brings together specialists from various disciplines that it would be not possible to organize with strong consortium of the organizers, and one of the crucial pillar is National Information Processing Institute, and therefore I would like to invite Dr. Engineer Jarosław Protasiewicz, Director of the Institute.
Good morning. My name is Jarosław Protasiewicz, and I am the head of the National Information Processing Institute in Warsaw, Poland. It's my great pleasure to welcome all of you to our annual Machine Intelligence and Digital Interaction, or MIDI conference. This year we are celebrating the 10th anniversary of the event. The MIDI conference offers a unique opportunity to bring together researchers and practitioners who work in diverse areas of artificial intelligence and human technology interaction. The 10th MIDI conference wouldn't have been possible had it not been for one man, Professor Krzysztof Marasek. He served as a member of our research staff at the National Information Processing Institute, and he was a true artificial intelligence expert. Between 2012 and 2018, he was a member of our Institute's Scientific Council. He was also the head of the multimedia department here at the Polish-Japanese Academy of Information Technology. He is sadly missed, and I am sure he would have been delighted to see how MIDI, his great project, has evolved. I sincerely hope that all of you find this conference inspiring and compelling. And I wish all of you fruitful discussion and stimulating case studies around the key subject of the conference. Thank you so much and have you great conference.
Thank you. The evolution of the conference also wouldn't be possible without the support of the System Research Institute, who, like National Information Processing Institute, joined the conference team in 2020. Now I would like to invite Professor Janusz Kasprzyk as a representative of the System Research Institute, Polish Academy of Science, to say a few words.
Thank you very much, Mr. Chairman. Ladies and gentlemen, I would like to say some words about this conference on behalf of the Systems Research Institute, but not only, because on behalf of the Computational Intelligence Society of IEEE, where I'm a member also. First of all, if we look at the conference, so there is something very, very interesting about this. If you look, for instance, at IEEE conferences and the conference of very many international organizations, so you see that the last period, COVID-related period, has had a very bad impact on those conferences. Many conferences did not survive. So this conference has survived for the last years, and this is a proof of vision of the organizers with respect to topics, and also about the strength of the Polish scientific community. So this is a very big asset, for all of us. And second, I would like to draw your attention to one of very important facts. So, look carefully who is the organizer of this conference. There are 4 organizers. There is a leading public university, Łódź University of Technology. There is a leading non-public university, the Polish-Japanese Academy. There is a leading research institute, the so-called PIB, OP, and also there is a leading institute of the Polish Academy of Sciences. So you see, there is every, let's say, aspect of the Polish science is covered in this conference. So this is very important because, in my opinion, there is a proof of how strong the Polish science is. Polish science is very strong, and I am telling this to you because I have been for so many years chair of award committee of the IEEE, and this is like you all, maybe you know, this is the leading body of for electrical, electronics, AI, CIS, and so engineering. The Polish community has a very good stature and very good opinion in that. So I would like to congratulate the organizers for this vision and hard work that made it possible for the conference to survive and to flourish. Thank you very much again.
Thank you very much.
So, ladies and gentlemen, dear colleagues, I would like to say a few words before we move to the next section of our formal invitation. So the keynote speaker, Professor Woźniak. I would like to say a few words together with Cezary. We are co-chairs with, of course, Professor Janusz Kasprzyk, and there are also other chairs who were unable to join us at the moment.
Yes, Dr. Romanowski and Professor Sikorski.
But they are with us, of course, and they will, of course, take part in this hybrid mode of the conference. However, as you may already notice or be familiar with, our conference have 2 major tracks: machine intelligence, that just stands for artificial intelligence and machine learning, and digital interaction, that is, we may say, broadly speaking, human-computer interaction, or maybe at a broader scope, human-machine interaction, but it also incorporates human-to-human interaction. And we would like, based on our current endeavors, we would like to extend this conference with a next track from the next year on. I mean, the track connected with space exploration as one of very promising and challenging area of research and practice. So
an area that incorporates,
of course,
partly both of the tracks we already have.
It's a pleasure for us that we this year we may let's say anticipate this track with the opening discussion panel with experts directly from European Space Agency, European Astronaut Center in Cologne. There is a specialized team called XR Lab. It's not a coincidence that our team also has a name XR Lab, because we do research and development in the area of extended reality. So various application of mixed reality continuum. I mean, from VR to AR and XR. So if you are interested, we have a special set in the corner of our room just to demonstrate how it may look like. Of course, this is not, let's say, fully fledged space station yet, but our colleagues from ESA XR Lab already have cooperation with NASA, and they develop such rich immersive environments, and we will join forces, or we has already joined forces, and we will extend this collaboration. So during our panel there will be guests from European Space Agency, from Polish Space Agency, and Polish Ministry of Education and Science, who are experts in this field, as well as members of our Human Aspects in Science and Engineering Research Group that formulated or postulated a long-term scientific framework program called Alpha XR. So we will drop a word on it later on, but this special framework program is intended to foster those endeavors in applying to research and practice training of XR technologies in the context of space exploration. So this is something which is in line with current state of the art, as well as current events. As you may be familiar, as our Vice President, Professor Wierzbicki said, the Orion module has just successfully landed yesterday. So this is a crucial part of the Artemis space program, which is the first in our recent history, I mean the first time for the last 50 years that we will be able to put our boots on the moon again. To use, let's say, yeah, we hope so. So this is our, let's say, new area of commitment to these European and beyond joint efforts to space exploration. So we hope that it will constitute, I mean, our endeavors, which will be mentioned and discussed during this opening panel, and later on we will try to, from next year on, to show you the updates, our current activities, research in ICE condition, I mean isolation, confined, and extreme, alongside with using the XR technologies, psychophysiology, multimodal data acquisition and analysis. So we hope that this will really constitute the new Polish commitment to this space exploration area.
And we will talk more in detail during the discussion panel in a moment. But first we can advance to the point in our agenda that we have before the discussion panel, which is a keynote speech by Professor Michał Woźniak. Can we confirm that Professor is connected? connected. Okay, I see that, yes. So Professor Woźniak is head of a department of systems and computer networks at the Wrocław University of Science and Technology. And his research focuses on machine learning, compound classification methods, classifier ensembles, data stream mining, and imbalanced data processing. And today, Professor Woźniak will be talking about tasks and challenges of lifelong classifier learning. Can you hear us, Professor?
Yeah, thank you very much
Great.
for the introduction. Good afternoon for everybody, and I think that we may start. I will share
great. The floor is yours.
Okay, the screen is mine. It's small. Okay, then good afternoon once again. I think it's better that I maybe I switch off the screen. No, okay, the camera. Okay, then today I would like to shortly introduce you into the new paradigm of the machine learning, which is usually called as the lifelong learning, lifelong machine learning. Mostly I will focus on the classification task, but to be honest, it will be this talk will be a little bit general. Firstly, when we talk about the lifelong machine learning, that we have to notice that nowadays there are many terms, there are many topics related with this. You see, for example, this cloud of words. There are some very popular terms related with this topic are presenter. Yes, now this currently is a little bit, let's say, the terminological confusion. Therefore, I will try to, during the speech, to precise what machine learning, lifelong machine learning is. The topic of the outline of the presentation will be as follow. Firstly, I will present shortly the motivation of lifelong machine learning. Then we will focus on some scenarios which could be realized under this umbrella. And also, I would like to answer the question: is we really need the lifelong machine learning? Then, if we have the time, I will say something about the few selected methods related with some task, lifelong learning task, and maybe some ideas from my team. And for sure, on the end, I will summarize and present some future works. Firstly, the motivation. Now, I think that most of you realize that when we propose or solve the real world problem, then we usually face with the problem of the continuous data. That means that we have to propose the system which can analyze the data the data in motion. That means that we should propose any methods which is able to analyze the streaming data. Usually, this cause that we need to produce, or we would like to produce the model as soon as possible, just to use it in practice, and then we would like to employ the new data just to improve the quality of the model. When we faced with the problem, we have also, of course, we should also take into consideration that the resources at our disposal are limited. That means that we are not able, for example, to store all incoming examples or incoming objects because of the memory limitation. As well, we have to realize that also we should answer as soon as possible. That means that we have also taken into consideration the limited computational resources. And now, if we deal with the data, especially with the streaming data, we also have to realize that most of the canonical model, they are not able to solve such a problem, especially because most of the models, most of the methods assume that the data is stationary. That means that there are no changes in the probability distribution. But now it's a well-known phenomenon which can appear in such a data, which is called the concept drift. That means that the probability characteristics of the probabilistic characteristics of the data of the data distribution can change over the time. And we have to propose such a method which can not only improve the quality of the model, but also follow the distribution change. And a quite new challenge is that we don't want only to solve the one task, but also we would like to solve many tasks. That means that we would like to imitate the human intelligence, which is able not only to be the expert in solving the particular task, but it also could be expert in solving many tasks in different nature. As the motivation, I will present you shortly the part of the article which appear in the Nature this year. In this article, you can find a very nice story, which is, I think it could be used as the motivation of this talk. One of the author being you, this is one of the guy who is the author of the very comprehensive handbook of the lifelong machine learning, described the story related with the control system of an autonomous vehicle. And this autonomous vehicle stopped at the middle of the road because it didn't know how to interpret a pebble lying on the road. And the question was, if this system which controls the autonomous car behave properly? Yes, the answer is yes, it behaved properly because it chose the safe decision. That means safe decision means the stop, because it didn't know what to do, because such an artificial intelligence system, which is responsible for driving the car, had not encountered such an event before. And I think that is illustrate very well the typical task solved by the AI. If we compare the learning, the human learning and AI-based system learning, then we can realize that people can build on what they learn, but also they are able to adapt as the environment changes. That most of the AI system are locked into what they already know. And what is the conclusion from this is that the typical machine learning task is rather isolated task or isolated learning, because it doesn't consider any other related information, or usually it doesn't take into consideration previously learned knowledge. But when human learns, then when human faced with the new problem or with a new environment, then we as a human can adapt our knowledge. We are able to adapt it to deal with the new situation and also learn from it. Over the time, we learn more and more and become more and more knowledgeable and more effective at learning. And machine learning or lifelong machine learning aims to imitate this human learning process and capability. And we can propose, or let me describe shortly the possible scenarios related with the continuous learning. We can propose such a very simple taxonomy that we have the task related with the learning of the one particular task, and of course some methods or some models which could be used to train models for the different tasks. Let's start from the online learning. Online learning is I think that's a very, very common and usually very old approach. But usually when we deal with the online learning or the learning from the stationary data stream, we assume that the data distribution is stationary. That's nothing changed in the distribution. The goal is usually to build a model as quick as possible and to use it, and the new data are used to improve the quality of the model. Pedro Domingos formulates several conditions for so-called online learners, and they are as follow. Firstly, he said that the good online learner system should process each object at most once. That means that it's not such a system is not able to memorize the incoming object. Of course, we also have to take into consideration, as I mentioned before, the limited resources, especially the memory resources. And also the last condition is that the training process can be paused at any times, and the accuracy of the model should be the same as the accuracy of the model trained in the batch mode. Batch mode, where the batch consists of the all previously seen object. A little bit different task is the learning from the drifted data stream. That sometimes such a task may be considered as the domain adaptation. The main difference is that we assume that the data distribution is not stationary. That means that it could change over the time. That means, of course, there's especially from the classification point of view, the changing in the distribution can cause the decision boundary, and then we have the problem which is called the virtual concept drift. And other case is that if it doesn't affect the decision boundary, then we have the virtual concept drift. And the question is, if we really need to rebuild the model or to improve the quality of the model to adapt the model to the new distribution, there are some different opinions on this. One of the opinion is that if the model works properly from the classification point of view, that it's not necessary to rebuild the model. But also there are some opinion, especially formulated by Leandro Minku, who said that especially for the interpretation of the model, it's very important to rebuild the model even if the virtual concept drift appear. And the second type of the drift is the so-called real concept drift. That means that the changes in the data distribution can affect the decision boundaries. And of course, in this case, we should rebuild the model. We should rebuild the model because the previous model is simply outdated. Of course, there are many concepts. I will not focus on the concept, but very simple approach is just to rebuild the model from the scratch. Yes, this is very naive, but usually we use some method which employ the adaptivity skills of the models. What is important in this case, because I will say something about the catastrophic forgetting, but in this case, please note that forgetting is our friend, because we shouldn't take into consideration the outdated data. That means that the old data which are coming from the old distribution should be removed from the learning material for the new models. And usually we use very simple approaches like a sliding windows, or also in my team we usually employ the classifier ensembles with the special attention to the concept of the classifier ensembles with the changing lineout where the oldest members of the classifier ensemble are simply removed from the ensemble. And then we have also several the question: if we require the learner to master the new knowledge, can we afford to train the model from the scratch? And the first question we should ask is also the question about the cost, because I think that sometimes if we carry the research, we usually forget about the cost of the training. Now, the retraining the model or build the new model from the scratch is very costly. Yes, and we have to answer the question: how much does it cost to train a model? And let's say we have the two correct answers. The first is depend, and the second a lot. And this is a very nice paper which appears there this year, and authors simply show the show the cost of model training. If you look at the cost, I sometimes laugh at my colleagues, younger colleagues, because now we are working on the one project related with the fake news detection, and I laughing at them because if they wanted to train a model from the scratch, they would spend about year's budget on my department on such a single train. Yes, this is usually impossible. Then, if we talking about the machine learning or lifelong machine learning, that, to be honest, we are not looking for the improvement of the state-of-the-art methods, of the state-of-the-art classifier learning methods, but rather we look for the new paradigm of the machine learning. We totally change the paradigm of machine learning, and we don't want to learn or to train the model from the scratch, but we would like to incrementally add new tasks that we would like such a learner which is able to solve the new task, of course, with the transferring knowledge of the previously learned task. And we can divide the lifelong learning task into the three groups. This is the nice taxonomy was presented by Van de Ven and Tolias, and they enumerate such growth. The first task is maybe not simple, but is conceptually very simple. This is called the task incremental learning. That means that during the training, models has always informed about which tasks need to be performed, and also during the testing, we also have such information. Of course, from the practical point of view, it's not so useful to have such a logic, because it's during the testing we need some additional information. For the real-time problem, especially for the human learning, usually we don't have such a label, because the human is able to recognize what task should be solved. Usually, the methods used for this, to solve such a task are methods which are based on, for example, the multi-head architectures of neural nets, or also the very popular approach is called the progressive neural network. The second approach is much more realistic, in my opinion, because it's called the domain incremental learning. That means that during the training, we still have the access to the task ID, but not during the testing. That means that the learner should not only solve the task, but previously it is responsible to recognize which task should be solved, or what the knowledge from which previously learned task should be used to solve such a task. That means that, for example, the example of this task, we have the agent who needs to learn to survive in the different environments, but without the need to explicitly identify the environments it's confronted with. And the last method, or last type of the task, it's typically for the pattern classification, is called the class incremental learning. That means that we have incrementally learn the new classes, or the group of the classes. Then let's move to the definition. What we really need? We need such a machine learning, or such a machine learning system which could imitate the human learning process and capability. That means that we need such a model, such a algorithm which can train or learn the new models, or learn how to solve the new task without forgetting the knowledge about solving the previously learned task. What is important for this case is that to solving such a problem, to train the new task, solving the new task, we don't need to have too many learning examples. Maybe, and it's also we also can imagine, because it's typically for the human learning, that if we collect enough knowledge about how to solve the many tasks, then maybe to solve the new one, we don't need the training objects. That means that we can say that we can train the model or learn how to solve the new task without the new learning examples. Of course, this is hard to imagine, but let's realize that the human can do it. Yes, therefore, why the machine cannot do it? If we would like to formalize the long life machine learning, then we can have to underline that the lifelong machine learning is the continuous learning process. We have the several tasks, we have the number of the tasks. With each of the tasks is we have the learning set, and of course there are no limitation or no constraints related with the character of the task. They can come from the different domain. When the new tasks come, then we need to collect the data related with this task, but we would like to transfer the knowledge from the previous task to the new one. And if we would like to propose such a lifelong learning, then we also would like the learner to be able to learn and function in the open world environment. That means that we require that the learner can learn the new task, but also we would like it to discover new tasks. Yes, because we would like let's say the active learner. That means that we need the learner to not only to train on the given task, but also discover that something new appeared. That of course we can employ some techniques we already know. For example, novelty detection. And if we have such a case, then we can summarize that when we have the lifelong machine learning, then it's a continuous process. We need that the knowledge could be accumulated and maintenance, and the learner is able to use the accumulated past knowledge to help future learning. And of course, as I mentioned previously, I would like it to discover the new knowledge. Of course, we still have to remember about the limited resources. Also, with that we only have the limited number of the new data at our disposal. And what technique we can use? I'm sorry that I skipped some of the slide because I like to control the time. The first, I think that's for sure what we need from the learner is we need such learner to employ the transfer learning. That means that we would like to transfer knowledge from the previously learned task to train how to recognize the object from the new task. Usually, we can if we deal with the transfer learning, then we can have more than one source domain, because usually when we have the transfer learning, that we have the source domain, we have the target domain. Usually in the source domain we have the many labeled objects, but for the source domain, for the target domain only a few. But we can also imagine that we can use the many source domain as for the lifelong machine learning. But usually when you look on the methods proposed method, usually we have employed only the transfer from one domain to one domain. Another techniques we can use so-called the multitask learning. Multitask learning, it learns multiple related tasks, and the objective function is to minimize the average loss function related with each of the task. More or less, if we imagine that, if we consider the multitask learning, that we can say that if we have the online multitask learning, that means that we train the task by task, that such a sequential multitask learning is thus the lifelong machine learning. And to illustrate the problems we face during the lifelong machine learning, let me present the very simple example. This example is given by Hongyu Li from NTU Taiwan, and he considered the very simple neural networks. Yes, very simple, related with 3 layers, then 15 neurons for each, and the experiments, so also only the illustrative experiments on the perturbed mist. And we have he trained the model on the task number 1 and achieved a pretty good accuracy, about the 90%, and then trained model on task number 2. And as you see, the new model, the new task is trained very, very well, but the old task, the quality on the old task is decreasing. Yes, that means that something is going on with this model. I think that you know that in this case the well-known phenomenon is called the catastrophic forgetting appear. Yes, that means that model simply forget the previously run task. But if we present 2 tasks in the multitask mode, that we train the models on the both training example from the task number 1 and task number 2, we realize that model behave pretty well on the task number 1 as well on the task number 2. That means that the network has enough capacity to learn both of the tasks. The question is how to combat this phenomenon, how to combat the catastrophic forgetting. The first very naive answer or very naive approach is that we can use the old data for training, but as you can imagine, this is very, very computationally costly. We can memorize all the data, but on the other hand, we know that we deal with the limited resources, limited memory, that we are not able to memorize all incoming objects, all incoming examples. Yes, we simply break the assumption about limited size of the storage. Therefore, simply we cannot use the typical multitask training in the lifelong machine learning scenario, but the multitask training can be considered as the upper bound of the lifelong machine learning. Another approach, we can also propose very, very naive approach. That means that we can train the model for each of the tasks. I know some of the application that let's say the owner of such a project doesn't take into consideration that it's possible to transfer the knowledge from the one task to another and simply solve each of the tasks separately. Yes, we can use it. Yes, there's not a problem, but we simply lost the ability to use the previously trained models, and also we have to let's say pay for the extra memory to memorizing all the model, and we simply don't use the possibility of faster train or simply faster train. Then if we compare the lifelong machine learning with the lifelong machine learning, this is lifelong machine learning with the transfer learning, then the comparison is very, very simple. Yes, because if we have the transferred learning, then we don't care about the previously trained knowledge. Yes, that means that we can solve the task number 2 because we know how to solve the task number 1, but we don't care whether it can still do the task number 1. But what we would like to do, that even if the learner has learned task number 2, but we need it to still behave, to still solve the task number 1 as well as previously, or maybe the degradation shouldn't be so huge. Usually that's I mentioned this phenomenon. Of course, this, I think most of you know. This is the catastrophic forgetting or the catastrophic inference. This described well in 19th of the previous century. This usually means that the new task is likely override the weights that have been learned in the past, and thus degrade the model performance for the past knowledge. Sometimes, but not sometimes, usually it was also referred to the so-called the stability plasticity dilemma, and because on the one hand, if model is too stable, then it is not able to consume new information from the future training. But on the other hand, if it's the plasticity is very, very, very high, it could suffer from the large weights changes and forgets previously learned representation. Yes, this is the idea. And how to deal with this topic, with this problem? There are several approaches which they are proposed for the lifelong machine learning. Firstly, let's note that if we deal with the learning the new task, then we can group the parameters of the models into the three groups. The first is the parameters related with the already trained task or already known task. We have some parameters which can be known as the shared parameters, and the parameters which are dedicated to the new task. And we have, roughly speaking, we have the three approaches for how to deal with this problem. The first is very conceptually each of them is very, very simple. But first is called so-called the feature extraction, and that means that the shared parameters and the parameters for the old task remain the same, but we would like to train only or to change only the parameters for the new task. The second approach is called the fine-tuning. That means that we remind the old parameters the same, that we protect them, but we would like to optimize only the shared parameter and the shared parameter and the parameter for the new task. And the last approach, probably most promising, is that we tune all the parameters. Yes, this is, for example, if we deal with the multitask learning, this is the typical approach that all parameters are jointly optimized across the task. And Lee Hoheim also present the following summary how such a method behaves for the new task performance, for how it behaves with the old task, and so on. And maybe because time is running out, I will only focus on the one particular method related with this topic, how to solve this parameter. I skip several slides, and I would like to say something about I think the very nice approach related with the regularized optimization. Yes, this is one of the strategy how to deal with the lifelong machine learning. This approach is related, for example, I think that if somebody is working with this topic, is related with, for example, elastic weight consolidation or the gradient episodic memory and so on. Yes, this is the very nice approach. And elastic weight consolidation was inspired by the observation that the human brain, in which elastic consolidation enables continual learning by reducing the plasticity of synapses related to the previous learned task. How it's worked? The idea is quite simple. Yes, consider that we have the two tasks to be trained, and the gradient, the color gradient, is related with the quality of the classification. This blue one is for the task number one. Then we start from the let's say one starting point, and we look for the best parameter setting to increase, let's say, the accuracy of our model. And then the new task appear. We have the next task. The idea is the same. This gradient is related with the quality of the classifier, of the classification of the task number two. And usually, if we forget or don't consider that we would like to maintain the knowledge about the task one, then probably we can solve this problem just to move or to change the parameters in this point. That means that we will be very good in solving the task number two. But let's imagine that, let's see that if we solve the task number two, then we strongly degrade our model towards solving the task number one. The best solution probably will be somewhere here, because we would like to maybe we don't maximize the quality for the both tasks, but we still have the good enough models to solve the both tasks. And how this method is solved? The idea is very simple. The conceptual is very simple, because we would like to formulate our learning criteria in such a way that we would like to maximize to minimize the loss for the current task, but also we have something which could be recognized as the guard for the parameters from the previous task. And the main concept is which parameters can be changed during the training. Let's consider a very simple example, which I think this illustrates very well this behavior of such a method. Let's consider that we have only the two parameters, the parameters θ1 and θ2, and we have the task number one. The gradient is related with the quality of the model. Of course, if we solve only this task with task number one, then probably we can set the parameter as the theta b. That means this is the best parameter for the task number one. And then we can consider which parameter can be changed. Let's notice that if we change parameter θ2, that means that we can degrade the performance on the task number two. But if we change only the parameter θ1, that means that such change could be, let's say, safe. It doesn't impact the performance on quality on the task number two. Yes, that means that if we have such a knowledge, we can simply select which parameters can be used to generalize the new task, or to generalize the new task, taking into consideration that we don't degrade the old task, the performance of the old task too much. Okay, and because this, I think that 1 minute left, then let me present the conclusion. I think that there's still room for improving to carry out the research on lifelong machine learning, but there's still some work which should be done. Firstly, I think that we still don't have the, let's say, the reliable evaluation protocol for the long life machine learning methods. Not only the protocol, how to evaluate the methods, but also we have the problem how to measure the quality of such a method. The second challenge, I think that's this also the problem that if you saw the methods or already developed methods on lifelong machine learning, they usually assume that the previously learned tasks are based on the stationary data, but it isn't true. And usually, if you train the model for the, let's say, the old task, that the data distribution for this task could change over the time, and you not able to maintain the previous model. That means that you, on the one hand, you can fight with the combat the catastrophic forgetting, but on the other hand, you also have to implement the methods how to forget outdated data from the already trained models. Yes, this is, I think, this is quite challenging task, and only a few works are already published on this topics. And the last observation is that the lifelong machine learning now is advanced conceptually, but there's still only the few practical application of lifelong machine learning. Of course, it's not true, there are no application, but I think that's many, especially from the practical point of view, many companies or many project owners, they simply decide not to transfer the knowledge from the previous task, or to maintain the system which is able to solve the many tasks, but better but they decide to propose, let's say, the simple approach, which is dedicated to solve each task individually without the knowledge. Okay, I think that's all. Thank you for your attention.
It seems very interesting, especially the connection with the concepts from psychology, disconnected with plasticity and, for example, forgetting, as we know, for remembering actually learning things for humans. It's very important to be able to forget. Thank you very much, Professor, for your talk. Now we are ready to move to the next point in our agenda.
So the opening discussion panel on XR-based research in space exploration. So we need just a few seconds to rearrange the stage, and we will start with our panelists here on site and remotely. So just give us just a few seconds.
A couple of minutes.
All right, dear guests, dear colleagues, we would like to move to the next part of the starting part of the conference, opening session. So right now we will focus on a short discussion panel on challenges and opportunities in space exploration using extended reality. So we will talk a bit about new technologies in the context of space exploration. As we said before the keynote, there is a coincidence of many interesting elements of this very conference and things that are happening around the world. In particular, this is the 10th anniversary MIDI conference, as well as there is a 10th anniversary of Polish joining ESA with Polsa. So that's why we have together with us Professor Grzegorz Wrochna from Polish Space Agency, the president of Polsa. So we would like to welcome you. We have also representative of Polish Ministry of Education and Science, who is responsible who is our connection to the ESA, European Space Agency, in terms of the new name of the exploratory program, I mean Terra Nova. So I think that Agnieszka will explain it in a few words in a minute. We have also with us Professor Banaszkiewicz from Polish Space Exploration Space Research Center. Yes, I'm sorry, because we are all familiar with the Polish name. I mean the CBK PAN, Centrum Badań Kosmicznych, Polish Academy of Sciences. So that's why it's one common for us. And of course, Professor specialized in robotics. So this is very vital part of our endeavors, our research in the field of space exploration and applying or interaction with humans. And that's why it's also with us Dr. Cezary Bile, who is the head of Laboratory of Interactive Technologies from National Information Processing Institute. We have conducted with Czarek and his Cezary and his team many interesting research so far on applying virtual reality, immersive systems combined with UX studies and things like that, and Internet of Things, many interesting things, together with Grzegorz Pochwatko, Vice Director of Institute of Psychology, Polish Academy of Sciences, and also head of VR and psychophysiology lab, with whom we also conducted a lot of research, and jointly with Monika Kornacka, who is with us remotely from Emotion Cognition Lab, Vice Director of Institute of Psychology, SWPS University. So the four of us are heads of we may say, or we say, just or leading human-machine interaction labs with the use of in context of new technologies like virtual and extended reality immersive systems. That's why, because this is the 10th anniversary of Polish joining to ESA, we tried to push this discussion forward, and we've postulated or formulated our let's say scientific manifesto called also Alpha XR research framework to facilitate establishing a new Polish contribution to space exploration. And we also started or initiated, thanks to the Ministry of Science and other institutions, direct collaboration with specialized laboratories from European Space Agency, especially EXER Lab from European Astronaut Center. And that's why with us are colleagues from ESA EXER Lab, Lionel Ferra, who is the head of this marvelous unit, and Tommy Nilsson. Their team directly cooperates with NASA with all those fancy models of immersive ISS, environments and elements of lunar expeditions. And together with us is also Professor Gabriel de la Torre, directly from Spain, who is the head of ESA topical team on space analogs and human performance. So this is vital, those VR or immersive systems, and also they are crucial for in terms of human robotic interaction as well. So those elements are interacting or interleaving more or less. So I would like to start our discussion with this fact that yesterday, yeah, the module Orion, the important part of Artemis program, which has successfully landed, and moreover, it was like 50 years from the time that the human feet just stood on the moon, and this last mission of Apollo program was also, you may say, extraordinary, because there were not only military jet pilots, but also there was a first, let's say, civilian astronaut, the geologist, who took part in this exploratory part of this program. So nowadays there's a chance that we may start again with the human exploration, and we have also our, let's say, Polish candidate to become an astronaut, and he is also a scientist from CERN, and Professor Wrochna used to work in CERN. So maybe I would start with Professor Wrochna. What do you think, Professor? Is there a room for a new Polish contribution in this European or maybe even broader scope of cooperation of national and international agencies of space exploration and things like that?
Yes, of course, there is a room. There's plenty of room, because during those 10 years of our presence in ESA, we developed a space sector. We now have dozens of companies who are specialized in space technologies. We have 400 companies registered to ESA tenders, 150 of them already won some tenders. So we are already well known to ESA. And we are becoming responsible for more and more important items of ESA missions. We participate in the preparation of ESA missions. In fact, we have counted that out of about 24 ESA missions currently being prepared or in fly, Poland is present in 11 of them. So almost every second mission has some contribution from Poland. And now we are more and more interested also in human exploration, and a sign of that is indeed a nomination for a Polish engineer to become an ESA astronaut. Reserved so far, but we hope one day he will join the main crew, and we will work on that to help him. So we would like to invest in preparing astronauts for the future flights to International Space Station, but also to the moon, and in the long-term future to Mars. ESA is contributing to the Artemis or Moon to Mars program, providing the service module behind the Orion. So it has a right to send some European astronauts. We are also talking directly to ESA. I talked to Pamela Roy, Deputy Administrator. I talked to Senator Nelson, the NASA Administrator. He's invited to come to Poland. So we also talk to NASA directly. But at this moment, we have this big chance of having an astronaut among the reserve crew. So to support that, we would like to contribute to this program, and a very interesting contribution would be what we are discussing today, some virtual reality, augmented reality, when we can help astronauts in training. They can be subjected to some environment which resembles the current situation on the space station, but also some kind of crisis situation could be modeled there. That's one thing. Another thing is what we have heard that there is a new specialty here. I mean, using the VR technology to study the performance, the well-being of the astronauts. This is very important because, I mean, if you rely just on some medical, physical measurements, you don't see what is really inside the mind of an astronaut, but observing his or her moves, his or her reactions to many different situations, you can predict some problems early on. You can introduce some countermeasures to prevent some problems. And you can help him or her just to relax. So I think this is very important contribution, and we think it's a really good subject to cooperate with ESA on that.
Thank you, Professor Wrochna. Yes, we also share your opinion about the importance of using new technologies in this context. So I would like to ask now directly our colleagues from ESA, European Astronaut Center, on their let's say more or less preliminary or in-depth impressions of using such immersive systems in the context of astronaut training or doing research in this area of space exploration. Lionel, Tommy, would you like to say a few words about what we have done so far and what's promising and still what we need still to improve, or what are the challenges right now from your perspective as a team who directly cooperates with NASA?
Hello, can you hear me?
Yes, we can hear you loud and clear.
Awesome. So I just wanted to say that a lot of people probably don't know about this, but it was actually the space sector that helped pioneer virtual reality in the first place. So namely in 1993, NASA pioneered the use of virtual reality to train their crew for the Hubble Space Telescope repair mission. But ever since then, it's been basically the private sector and companies like Meta leading the way on adoption of virtual reality. So what we're trying to do now is kind of to close the circle and help the space sector take full advantage of this technology that it originally helped to pioneer. So we're looking into plenty of different potential use cases where virtual reality can actually be really useful, starting from astronaut training and things like design reviews and also, not least, public engagement. And so I don't know if you want me to cover any of these, or if Leona wants to add something.
Well, I can add a few things if you don't mind, Tommy.
Sure.
First of all, thanks to all of you to have invited us to this conference. It's well appreciated, and we also appreciate the enormous amount of work you have invested in Poland to be part of this space family throughout the years, and we are more than happy to help again in new horizons, being this new technology, and we are in close contact with you, of course, to enable new projects. And among the projects we have, as mentioned by Tommy, we have dozens actually of projects within ESA. Many of them are in the area of human spaceflight, where Tommy and myself are involved, but we also have other projects within ESA which are beyond Earth, which are in the order of Earth observations and also operations. But I think what was mentioned by Tommy, which is extremely useful for us, is really to be able to model things that the general public cannot see. And that's beyond the astronaut training and beyond the design review that we have conducted in VR is of utmost importance because, as you know, from a political standpoint, we would like to show to our taxpayers what we are actually doing in space with the taxpayer money. And this is one unique opportunity with virtual reality to really depict what we do. And this we have also done it, as Tommy said. So that's an important branch, not only to the public but also to the political level. And yeah, to reply to your question about the challenge, we have, as I said, multiple projects. Many of them are in the areas of astronaut training. So we do have now a training system which is for robotics. We are almost ready with a new training system also in VR for a training spacewalk, and also for the moon's surface and around the moon with the gateway. we have different tools to get trained and also to prepare, to best prepare our module to fly there. So we work closely with industry to do ergonomic design review where we involve crew in reviewing the current design with the industry. So all these projects are a constellation of different actors, industry, but also internal development at ESA. And I will be more than happy to welcome Slavoj whenever he is available to review one of the design or to take part in one of the assessments. Well, we can talk for a long time. One of the challenges I think I would mention is the haptic. So we have done many things in VR, some project in AR. We are engaged now in mixed reality. But the common pitfall in all this technology is that the haptics still have a long way to go because it's very hard to feel and assess, for instance, the weight, the volume, the resistance, and your body position right now in space or in partial G. And this is an area where we are working hard to see if the haptics can be definitely improved for space exploration.
Thank you, Lionel. It's very important issues that you mentioned, and one of this is related to robotics. So that's why I would like to ask Professor Baranskiewicz to say a few words on potential opportunities, but also challenges in terms of human robotic, but also maybe purely machine interaction.
Thank you very much. Thank you very much for inviting me. Currently, I represent the branch of Space Research Center in Zielona Góra, which is Dynamics of Satellite Manipulator Lab, and this is this robotic connection. And what we do there is to sometimes find a way to produce autonomous algorithms for satellite manipulators, but also for planetary manipulators that work in the real time, which is a challenge. So we have good control mechanism, control algorithms, but if they are good, they are costly numerically. And then we need to use accelerators. So this is one thing. Another is that to be autonomous, you need to recognize your environment using artificial intelligence, for instance. But now the connection to the virtual reality is that, as you know, it's very difficult to test whatever device on Earth in space conditions without gravity. We use, for instance, in our Warsaw headquarters, we use air bearing table, so you can test frictionless movement of objects in 2D gravity-less conditions. We also plan to have a lab in Zielona Góra with a pool, with the basin to have an underwater robot, and you can compensate gravity on expense of having it in liquid, which also requires some compensation. But if you want really to test it, you have to use some clever combination of two robots, that one simulates the target in space, another the servicing satellites. I refer to the space debris removal, for instance. So the idea that come to us is to somehow use the virtual reality not for humans, but for robots. So to fool their senses in a way that they feel as they are in the space environment, either on the orbit or on the planetary surface. And of course, you can also use some clever methods to fool them with what concerns the gravity. So this is the one of the projects that we introduced to the program of space technology partnership in Lubuskie Województwo, and we hope to start next year to go in this direction. So this is is a field of cooperation for us. But I want to also to mention two other aspects that are more connected with the human testing human exploration. One that there will be a lab for space medicine in this space technology park that we are developing in Zielona Góra. Somehow with the similar program as you carry out here. So psychological effect of being in isolation and so on. But there also is a project on a underwater habitat, which also could serve as a place when you can do a lot of experiments in isolation. So these are our plans in short.
So thank you, Professor Banaszkiewicz, and your answers lead us to Professor Gabriel de la Torre, who is the head of ESA topical team on space analogs and human performance, which is currently in the middle of a process of recognizing the network of existing facilities and the process of assessment and making recommendation for ESA. So, Professor de la Torre, would you just drop a word on what are those challenges in conducting such a research and why it's so important to have a better grasp of the existing and planned infrastructure for both human, let's say, human-computer or human-machine interaction, and combined with research and practice of space exploration, also in terms of those robotics and interaction and these extended or immersive environments?
Yes, first of all, I want to thank you for the invitation to participate in this panel. Yes, some of the panelists already pointed to very interesting points, like using VR not only for training, but also for well-being and countermeasures. And also I think that space analogs represent a good opportunity to test some of these technologies. I know that you in Poland have some of them, like Lunares station, for instance. So I think that you can use these space analogs to test these technologies. I also like to point that we have to consider also combining technologies like VR with the brain-computer interface, eye tracking, etc. So this is going to be very helpful for human performance. And the mission of this topical thing is to summarize not only the space analogs available right now, which are increasing in number, but also to define like priorities and in which ways these space analogs may help for fusion exploration that we can see it now more near with the Orion mission. So yes, I think the space analogs are a very good opportunity to use this technology. Yeah.
Thank you, Professor de la Torre. Thank you for this important voice in our discussion, which leads us to Dr. Agnieszka Kuczała from Polish Ministry of Education and Science, who may just shed a few light on what are real opportunities and real challenges in those, maybe quite bold, endeavors in, moving forward those transdisciplinary research.
Thank you very much. It works? Okay. So at the beginning, I would like to introduce a little bit my work. What I am doing in the ESA system. So I am one of the many delegates to the ESA program boards, which deal with the programs, many programs that ESA is leading. My program board, PBHME, is related to the human and robotic exploration. Currently, this is the program called Terranova, also known as E3P. This program consists of 4 cornerstones. the first of them is the humans in LEO, low Earth orbit, so the activities on the ISS. The second is humans exploration beyond low Earth orbit, so it's all the activities preparing the gateway, so the orbiter around the moon. Then the third cornerstone is related to the moon robotic exploration. And we are very involved in, we hope we will be very involved in this cornerstone. And the fourth is the Mars robotic exploration. Besides those four cornerstones, there are also two elements of the E3P Terra Nova. One of them called expert, developing the low TRL technologies, and space, science in space environment, science-oriented element of the E3P. And the last element of the program would be the most important in the context of our today discussion. Because XR, the extended reality, virtual reality, augmented reality, all we are discussing today is very much science-oriented, and it's also very useful for the astronaut training. So this year in Paris, the ministerial council of ESA member states has taken place in Paris, and this is the event, very important event, when the subscription of the ESA member states are decided. And this is also an occasion to have a deeper look into our space sector, our national space sector, the global challenges and opportunities, and our financial possibilities as the member states, our affordability. But we've seen that this program, the exploration program in ESA, is a really unique occasion to take part in something very important, because that's the beginning of our very important exploration endeavor. We are going to the moon, and we will need a lot of competences, a lot of new competences, not only for robotic exploration, but also for human exploration. So we decided, we as the Ministry of Education and Science, we decided to recommend a significant increase of our subscription to this specific program, the exploration program. So after the numerous analysis, talks with the ESA representatives, we recommended that our subscription will be of 12.5 million euros. It's not a lot comparing to the actors like France, Italy, Germany. But for us, it's a great increase. And what I would like to stress, it's also a new entry for the Polish actors, because it's not a secret that the exploration program is quite an elitist program. And on the one hand, our industry is very well doing in this program, is striving to have more and more contracts, and is entering into the into this market and competing with the actors, with the entities, companies that are very well established in this market. And the barrier of entry is very high, but on the other hand, there are some opportunities that are quite new. And I see that extended reality or these new technologies that we are discussing here may be this new opportunity for Poland to enter into the market as a very not only a new actor, but only an actor with very important competences.
Thank you, Agnieszka. So we hope that yes, we may be as a research group and a team of collaborating institutions, such a new power in this European or even maybe global market of space exploration with human elements. So that's why I would like to ask Grzegorz, one of our leading psychologists in our research initiative. What you think, speaking of those, let's say, maybe not extensive but substantial founds, on the other hand, compared with the challenges which goes from such a diverse, multidisciplinary, multimodal research. We have just started within our research group such a research, but what's your impression on, are we really, is there really potential at our side, at Polish side, to contribute or not?
Well, I guess it is, and it's my pleasure to represent the Laboratory of Virtual Reality and Psychophysiology in the Polish Academy of Sciences. We are one of the leading institutes in the Academy, so this gives us this opportunity to also have a very good and very well-equipped lab. And that's why I'm optimistic about that. Not mentioning that applying new technologies allows us also to actually lowering the costs of making a lot of very interesting studies. We are applying virtual reality for we are one of the first labs in Poland that actually combined virtual reality and psychology, and we are actually aiming at further developing methods of studying how humans behave in virtual realities, and combine this with psychophysiological data and real-time analysis of psychophysiological data. This is not easy task, actually, but also I would say that it's very promising as we have those joint initiatives, joint research projects that proved to be actually successful. So application of virtual reality technology, psychology, and psychophysiology in real-time data analysis allows us to both train people better, predict their behavior better, because there is no better opportunity to predict behavior than to observe actual behavior in various situations, and these situations are easy to simulate in VR. Combining the techniques of real-time data analysis and real-time modification of VR environments also allows us to be more flexible here and to develop some techniques that will be useful not only in space exploration studies, but also many other disciplines will contribute from this. So we then extend our scope also to other domains, including, for example, art. combination of art and science here is one of our main features, one of our main goals.
It's really interesting, Grzegorz, what you are saying, because as you of course know, but I don't know whether every panelist is familiar that our academy is not only one of the leading technical universities, but also have a quite decent and well-established new media art department where the 3D modeling and things related to VR, XR are happening right now. So speaking of those applications to the real-world problem from this space exploration area, I would like to ask a question to our remote panelist, Dr. Monika Koronacka from SWPS University, also one of the pioneers of those VR techniques in psychological data gathering and analysis, including eye tracking and things like that, but also momentary assessment used in our preliminary studies. So, Monika, what do you think about applying those methods and tools not only to the space exploration, but also what's the potential contribution? I mean, the intervention both on Earth and there in space.
So, as Grzegorz mentioned, the research in this area reflects quite well the challenges and opportunities that we're having in psychological research in general. I will mention two of those challenges / opportunities that I find particularly important. So the first one is transferring our research from the lab into participants' everyday life. And this everyday life might be very particular, like, for example, everyday life of astronauts. And using virtual and extended reality gives us a unique opportunity to transfer our classical lab measures, for example, psychophysiology, classical self-reported measures, but also executive functions measures like eye tracking into more ecological conditions, or even into fully ecological conditions using extended reality. So this is the first point. And the second one, also very important, is that for a long time in psychological research, including also psychological research on well-being and mental health of astronauts, we were focusing on a very particular fields, for example, on performance or on subjective well-being. And we all know that our emotion regulation is closely linked to our executive functioning, to our mental load, to our performance. And using external and virtual reality gives us this opportunity of passively collecting data, for example, using psychophysiology, using eye tracking. And this passive collecting of data on executive functioning, on well-being, on cognitive performance will enable us to model participants' well-being and to prevent mental health. As, for example, Professor Wrochna mentioned that previously we were focused, for example, only on psychophysiological measures. And nowadays we can use the network approach to detect some well-being issues at the very early stage by merging psychophysiology, self-reported data from ecological momentary assessment in everyday life, and with, for example, fluctuation of executive functions also during everyday life. So I think using VR and XR gives a great opportunity to focus in a very holistic way on well-being and mental health prevention. And as I mentioned, those two factors were quite often omitted, but they are crucial always, also from the perspective of performance and being effective in everyday tasks. Thank you.
Thank you, Monica, for this really insightful comment together with Grzegorz. And this is a very short panel. And as I said, this is a kind of anticipation of the next iteration of MIDI conference, I mean MIDI 2023, that we hope that we will establish a fully fledged third regular track on various aspects of space exploration, including human, machine factors, robotics, everything underpinned with artificial intelligence, so other themes of the conference, and also in general human-machine interaction. But I would like to ask you, Cezary, because we also conduct some transdisciplinary research on brain-computer interfaces or EMG interfaces, together with other colleagues, with other research institutions, in the context of potential hitting the market with new approaches to smart environments, smart homes, smart cities, but it may be also applicable to let's say astronaut training or even functioning in space, and then contribute back to Earth. What do you think about it?
Okay, I think that it's of course possible, but before I go back to your question, I'd like to make a short comment regarding what Grzegorz and Monika said, because I think that very important thing that characterizes virtual reality, and its results from our studies, that it's not a technology that you use, but it's rather the technology that lets you transfer to other environments, other places. It's not perceived as using, like for example, using a mobile phone or a computer, but it's described by people as transferring somewhere else. So what is a better way to transfer to ISS? At least partly. Yeah. So this is one thing that I think it's very important, because this is not it's not the difference of quantity, but I definitely feel that it's a difference of quality regarding to comparing to other technologies. And the second thing, also partially mentioned earlier, is thing that we should remember that psychology is a science of behavior. This is the core of psychology treated as a science, is to measure behavior, and it's very it's maybe not very easy, but virtual reality gives opportunities that were not possible before regarding measuring the behavior of people experiencing this technology. And I think coming back to your question, I think that using sensors could be also a part of this idea to measure behavior, and we can measure it for different things already mentioned before. For example, to test the well-being, to test the effectiveness of training, and so on and so on. The easy thing that gives virtual reality, its power for this scenario is that on one hand we can create the environment exactly with the properties exactly as we want them, and on the other hand we can measure the behavior. So I think that's the important part. And of course we should try to combine it with other things like brain-computer interface or eye tracking or other measures. But in virtual reality, we have the most basic measure, that is the movement. Yeah, because when someone uses VR, it has to use the controllers and it has a headset. So we have movement of head, and movement of hands.
So Grzegorz, ad vocem.
One little thing to this, because this is actually the moment in which we realize that the technology actually has to become transparent. We are not focusing on technology in here. We are focusing rather on the way we are using this and what opportunities it gives to us. For example, well, we are speaking about a human in technology, and one of the presentations that we will have during the conference will be on co-presence. That is the feeling of being present with another being in the same place, which is physically could be totally non-existent. Yeah, and we are speaking, of course, all about existing people and non-existing people also. So not,
you mean
not
aliens?
Beings? No. I mean, for example, artificial agents that also could be used to maintain well-being. So what is our role here is not to focus on developing the technology, or maybe focus on developing technology to the extent that it will remain transparent and serve us. And this is what we do.
I think if I may add one more thing, I also think that the power for our group, I hope for the future, is that in order to, this is also from our experiences conducting research in VR, that in order to be able to conduct such research, there are many areas that need expertise. Programming, like you mentioned, 3D design. We also need knowledge from psychology, but also from the realities of being on a mission in space, and so on and so on. So and it's very hard to create this synergy that would include all of these needed parts, and I think this we really have a great chance.
Alrighty, so just to wrap up, I mean, it's a pity that as every discussion panel, or majority of them, when the situation warms up and there is a chance for a real discussion, we have to unfortunately cut our discussion. But this is not ceasing our discussion; it's moving it online. We will discuss those topics during the conference, which is in hybrid mode, and we have we hope that together with our great guests, Professor Baranszkiewicz, Professor Wrochna, Dr. Kuczała, and colleagues from ESA, XR Lab, and also with other colleagues from the network of Topical Team, we'll continue this discussion, and ultimately, we will meet next year, and we will see what happened in this year, because this was actually our, let's say, only 1 year preliminary studies, 1 year of preliminary studies, preparations, also citizen science engagement. I mean, various events with students from, space hackathons or game jams, thematical with thematics with thematical game jams with space exploration, connected with space exploration. But if we were to just summarize in one word, each of the panelists, is there a real possibility to make a real change and make a real new quality of exploratory research using this potential that we discussed? I mean, the Polish potential in the context of international collaboration using XR technologies. So maybe Professor Wrochna.
You said one word, so instead of possibility, I would say necessity.
Thank you so much. Yeah.
Yes, of course, and we count on you.
on us, I mean. Professor Wanszkiewicz?
Yes, I join my predecessors. I'm for it. So I'm.
Thank you so much. And we will kindly ask our colleagues at ESA XR Lab, what do you think about this potential? Is it viable and is it worthy to join forces?
Totally. I mean, there's never been a better time to do space VR and mixed reality than now. So I think the next few years will be very interesting. So yes.
Thank you so much, Tommy. Unfortunately, Professor Gabriel de la Torre is not with us anymore. So maybe Lionel, do you have any comments on that?
No, I fully agree with Tommy.
That's great. You represent the same institution, so it's good to know that you have the same perspective. Thank you so much, Lionel, for taking part. So, Monika Kornacka, what do you think?
Yeah, and I think it's a great opportunity, not only from the perspective of applied science, but it can be also a great contribution from the perspective of basic science.
Oh, that's interesting. So what do you think, Grzegorz, about the basic science? Because psychology is one of the basic science.
Fundamental studies is what I do every day. So yeah, yes. And I would add also, not only next year, but we have to think about the further future. So I would declare that I would like to be here in 50 years, like we've seen. I didn't see the landing of Apollos, but I've seen the landing of Artemis, and I hope to be here in 50 years still to show you what we did. Actually, that's
great. And what about you, Czarek? Because we are pretty much in the same age. So
potential is great, and this vision is really appealing.
Well,
to be
potentially
here in 50
we have chance to do this. So let's do it, guys.
Alrighty, so what I can say, our specialists, I mean our scientists, our researchers from our XR Center will fully support every endeavor of our joint initiative. So we'll see next year, and we will wrap up what was possible to do, what was our current challenges and opportunities from the next year perspective. All right, so thank you so much. Thank you, our dear guests and panelists. Thank you. Many thanks for the audience, and there will be a lot of more room for discussion during the lunch break and later on during the conference. And we hope to continue our discussion multilateral after the conference. So thank you so much once again.
Thank you for participation, and I would also like to thank all the people connected on our Zoom platform. There are several people connected, and one more important thing that we for the next 3 days of scientific program of the conference, we meet using the same link on Zoom. If you haven't already registered on the website, please do so, and hope to see you in the next 3 days and now during lunch.
Thank you so much.
Thank you.